So welcome everyone to our weekly call after a short hiatus. So welcome back. Good to have you all on the call. Um, Let me share my screen. So just a reminder, the main topic of our call today, we'll be talking about measuring DOE performance. And in fact, Rishabh is with us on the call, so I'll introduce him in a moment, and he'll give some highlights from a paper that he and I think some colleagues wrote a short while ago, and just talk about the results of their experimentation. Once we've done that, we'll touch on some recent developments, some of which I think will be particularly topical. We will revisit over the next few weeks, of which you'll see when I run through some future call topics, and then we pick up on any other business. So pretty much following the format of our recent calls. So hopefully no surprises there. So let me stop sharing at that point. And if I ask Rishabh if you want to sort of switch your camera on and a screen share, that will be tremendous. And whilst you're doing that, as you may have seen from the call reminder, I think right in saying, Rishabh, you're now with AWS, but previously when you wrote the paper with the University of Illinois. Which you sort of co-authored with a number of sort of fellow members of the university. I just see my line sync seems quite lossy. I'm not sure what I can do about that, but I'll investigate that whilst maybe Rishabh is talking. But in the meantime, let me, in case you don't have it to hand, I've put in the chat the URL for the paper. Which is also on the on the slide. But anyway, so you can sort of capture that for review at your leisure. But without further ado, Rishabh, if I hand over to you, and please sort of take us through the sort of highlights from your paper.
Hey, thank you so much, Andrew. Thank you for that. Yeah, just give me a second here. Sorry. Hi. So, hello everyone. I'm Rishabh, and today I'd like to talk about some of the work I did on measuring DOH performance while I was still a master's student at University of Illinois. And I'd like to talk about some of the experimentation, how we went about obtaining this data, and some of the interesting things we found out about after we had this set data. So. It's been what, like 3.5 years now since the RFC for DOH came out. And ever since, the RFC came out, academia has set out to basically measure the performance of DOH. Academia has been doing research on, let's say, the cost of DNS over HTTPS. We've been comparing DOH with traditional DNS over TLS, and a lot of research basically to answer the question, can be as fast as traditional DNS? Now, sorry, I thought I heard something. Never mind, sorry. The major in the previous slide shown in these studies were taken from these 5 countries as highlighted in the slides. And thus there was a lack of measurements on a global scale. Basically, we asked the question, what about the rest of the countries? So the aim, with this paper, with this study, was that we wanted to compare DNS over UDP, which we also call DO53 in the paper, with DOH for as many countries as possible. We wanted to see how it was performing all around the globe. And we wanted this data because, we wanted to see how does the performance impact when you're shifting from DO53 to DOH? How does this performance impact differ across countries? And what are some of the variables and differences? And we believe that these are some important questions, and because the answers to these questions, they guide important policy decisions that I guess are essentially being taken right now. So let's talk about how we obtain this data in the first place. The first issue that we faced was, of course, the massive scale of the problem. We needed data for as many countries as possible. So for that, we decided to use Bright Data, which was formerly known as Luminati Networks. So Bright Data is basically a proxy network that let us proxy our resolution requests through their clients or exit nodes. And when we published this paper, Bright Data had more than 72 million rotating residential IPs across the globe. So we found the fact that they had, IPs in residential areas across the globe very helpful. This is like the market we wanted to capture. We wanted to see, we wanted to work with these residential IPs instead of IPs located in, let's say, commercial zones, where you would expect um, internet internet speeds to be better. So so we use Bright Data to proxy our resolution requests through their exit nodes. And another thing we did was that the domain name being resolved was actually under our control. So this is the entire flow of a request when it's proxied through Bright Data. So I won't go too much into detail about this diagram, but there's a few things I'd like to highlight. Um, the first thing was that these two boxes highlighted in blue right now, these two boxes are the boxes we essentially had control over: the machine we were measuring things on and our authoritative name server. So these are the only two machines that we could measure things from. We could see what was happening. And the data we actually needed is what's in the boxes highlighted right now, the area highlighted right now. So there's a lot of extra time involved in this whole flow that we needed to subtract to get accurate data, to get the data, to get the time it's taking for a domain name to be resolved using DOH. So we came up with an equation which ended up looking something like this. To get the data we needed. And if you are curious about how we came about this, please, I encourage you to read the paper. So when we got this equation, we wanted to verify that it was correct, that it was giving us accurate results. So we did some ground truth experiments, and we found out that the error between values obtained using this equation and the actual values, that error was lesser than 10 milliseconds. So that was a green light for us. We wanted to we were satisfied with this margin of error. Once again, if you're curious about what these ground truth experiments were, that made us like very confident in our methodology, please, I encourage you to read the paper. So in the end, we had data from 22,000 unique clients across 224 countries. These clients were present in 2,190 different autonomous systems, and our authoritative name server saw requests from about 1,900 unique recursive resolvers. So yeah, let's dive into some of the interesting things we found out after gathering all this data. So what this figure here is showing is the median DOH resolution time per country, and it's showing that for 4 different resolvers. So we decided to conduct, we decided to measure things for 4 different resolvers, which were Cloudflare, Google, NextDNS, and Quad9. So this is the median DOH resolution time per country for each of those 4 resolvers. And what the black stars indicate in each of these figures is the points of presence of these resolvers. So they are basically the locations from where our authoritative name server received a request from. Um, so we believe that these are the geographical locations where the machines for these resolvers are present. So these are essentially the egress locations from, which for the result, the egress locations for these resolvers. So the first thing we saw was Cloudflare had the best performance out of all of them, and Cloudflare did also have the highest number of pops out of any one of them. Uh, but when we compared Google and NextDNS, one thing stood out. It was that a higher number of pops does not necessarily mean a better performance. Google performed better than NextDNS, but had a lesser number of pops. So yeah, a higher number of pops does not necessarily mean a better performance. There are other factors, that are coming into play. So next, we obviously wanted to look at the performance inequality across countries. So we wanted to see the slowdown when you went from DO53 to DOH. And we found out that 8.8% of the countries actually had a better performance after switching to DOH. They did not have a slowdown. They essentially had a speed up when they moved to DOH. And this was in stark contrast to countries which lie at the tail end of this CDF. And these countries saw slowdown of more than 200 milliseconds when switching to DOH. For example, Timor-Leste saw a slowdown of about 670 milliseconds, a median slowdown of 670 milliseconds, and Cuba saw a median slowdown of 400 milliseconds. So, really highlights, there are some countries which are having a great speed up, and on the other hand, kind of, shows you the divide. Okay, so the next question we asked is, are these clients actually talking to a POP which is nearest to them? So what we did was we took the publicly available data set for the locations of the POPs for each resolver. And for each client, we saw, hey, is there a POP that is actually closer to than the one you're already contacting for this particular resolver? And if there is, we calculated the distance between them, and we call it a potential improvement in distance. Now, I do want to mention here that, yeah, geodesic distance does not perfectly capture network distance, but we still used it as an imperfect proxy for network distance. And we found out that 10% of Google's clients and 26% of Cloudflare clients can be switched to a POP which was at least 1,000 miles closer. So, if there is a POP that is at least 1,000 miles closer, we definitely believe, the, the network distance would also be lesser in this case. Then, we wanted to look at what are some of the variables that actually help explain, the slowdown that's happening. And we built some logistic models and some linear models. And one thing stood out. It was that internet infrastructure investment is one of the most determining factors. And for internet infrastructure investment, we decided to use the bandwidth of the country and the number of ASs in the country as a proxy for measuring, what the internet infrastructure investment is in that country. So our logistic model actually showed that clients who live in a country with a low bandwidth, they're 1.8 times more likely to suffer a slowdown as compared to clients who live in a country with a high bandwidth. Similarly, clients living in a country with a low GDP are twice as likely to suffer a slowdown as compared to clients that live in a country, with a high GDP. So, I just want to conclude this talking about, what we can take out from this, and some of the areas, I guess, research can proceed in the future. The first thing is we believe that users in highly impacted countries should be made aware of the performance degradation that comes with switching to DOH. And vendors should also think about making DOH more of an opt-in feature for such countries instead of the default. We wanted to make sure that providers were aware that clients there are a significant amount of clients that are not talking to their nearest pub, and maybe providers could do something to ensure clients are talking to the nearest pub. And one of the biggest things about our research was that we only considered cache misses. So, any research that actually considers cache hits, which is, of course, an important part of the whole DNS ecosystem. Any research that measures and takes into account cache hits, that would help inform further policy decisions, and would help research in this area. Well, thank you so much for listening to me.
Great, thanks, Rishabh. Does anyone want to come in with any questions? And if so, can you either use the Zoom tool to raise your virtual hand, or put something in the chat? And I can see Kurt has already done that. So question from Kurt, how long did the test run for, Rishabh?
So this was over 2 months, April 2021 to May 2021. Yeah, so 2 months.
Okay, great, thanks. Give others a chance to unmute. I can see a raised hand from John. John from Quad 9, just for context, Rishabh. Fire away, John. You might want to unmute.
Yep. Hi. So I think this is a really interesting study, but I know you and I had a short private conversation about this as well, but I'd like to highlight for the rest of the group that the database for geographic proximity is the free MaxMind tool, which we have found to be, I'll be polite and say, significantly lacking in accuracy, especially with our IP addresses in particular. I think that there is some improvement there to be made, certainly for Quad 9, but I think that some of the because of course we're looking at this from our perspective, but some of the geographic discrepancies were, I think, a little bit more accentuated due to some of the geographic problems with that data tool. I'm still very interested in seeing this run with a paid version or with a different data set to see if that gap closes up a bit.
Thanks, John. And I noticed, by the way, that I think Quad 9 was showing the best performance in Scandinavia, just interestingly. I guess that's prior to your recent announcement of additional infrastructure in Europe. So that's a pretty good sort of starting point in Europe, at least, if nowhere else. Are you planning to? So I'm not sure if you heard that, Rishabh. Are you planning to do any further sort of reruns, or is that an exercise for sort of new students within the University of Illinois to consider?
I would like to, continue in this area, but kind of busy with a corporate job. So yeah, we don't have a plan about rerunning this and the funding for this, because bright data does cost a bit of money. So yeah, that's a big question mark there about rerunning this.
Yeah, fair enough. Okay, thank you. Zaid, you've got your hand raised to unmute.
Yeah, just could you expand on maybe the reasons why you saw an uptick in DO performance over DO 53, given that theoretically it should be a little bit more?
Yeah, so theoretically it should be a bit more. So one of the things so there's two aspects. One is something that the data shows, and second is speculation. So the data showed that the countries which did see DO performance being better than DO53 performance, 80% of the countries had a higher GDP, and 90% of the countries had 90% of the countries had a higher number of ASs. So the data showed that these countries were countries with better internet infrastructure, infrastructure investment. So the speculation, there's a bunch of things we can speculate on. Maybe so DO53 is a default is the default behavior of the client. So maybe it's something to do with the ISP. Maybe it's because the ISP itself is not as as what's the word I'm looking for? It's not as better performing as, let's say, some of the DOH resolvers, like Google Cloudflare Quad 9. Also also when you're resolving a domain name using UDP, it does each box along the way has the ability to actually see what domain name you're resolving. And whenever we conducted experiments when we wanted to resolve a domain name using UDP, we saw way many number of requests asking to resolve that name. So maybe each of the boxes along the way the packet is traveling through is actually doing a UDP request of its own that's slowing it down. So yeah, there's a bunch of speculations there, and we know that Cloudflare, Google have invested a lot, and Quad9 have invested a lot.
Right, did it just me, or is the sound dropped out?
Hear you.
Okay, good. Yeah, maybe sort of technical challenge at my end, but okay. Well, yeah, thanks for that, Rishabh. I can see a couple of questions in the chat, so just picking up on those. Question from Hanny. Did you account for the difference in the UDP resolvers load levels compared to the DO servers, Rishabh?
Account. So DO53 resolvers, I'm assuming the the resolvers used at the ISP level or the default behavior. So anyway, we didn't want to account for any of these differences because we wanted to see, hey, what is the default client behavior and what would be the performance impact if they were to move to DOH resolvers. So we wanted the load to be as it is. I guess if you're talking about the load because of our requests going through, we expect for DOH resolvers, we expect to be way less than the load they're currently facing. So we're just like a small tiny dot in like the load they're currently facing. If I got your question correct.
Yeah, so I think just to rephrase that, so you weren't optimizing the testing, but very much sort of testing what the sort of the real world infrastructure performance was in each case. Yep. Yeah, fair enough. Okay, just scrolling down the chat, I can see Kurt said he's a bit puzzled by the possible correlation between slower day performance with less GDP income countries. This seems worth investigating more why this might be the case. So I guess, I mean, you've talked to that a bit. I think Rishabh, unless there's anything else you wanted to add on that. No. John has then added, while it may seem obvious, this seems really to be a measurement of peering efficiencies at the root of the speed question. Not only that, but significantly, this seems to be the case, which I think is more a comment than a question.
I suppose the question would be, are there any studies that look at peering efficiency or peering distances, AS path length, that could be overlaid to this that would make any sense to explain some of these, the deltas?
Yeah, I think in our, when we set out to read the related works, we didn't find anything that actually looks at the peering efficiencies. But yeah, this is, as you mentioned in the email, this is this definitely should be considered for future research, and I guess this is a great area to look more into.
Well, as you said, the reality is you are measuring what a typical user in a given country might experience, notwithstanding what the differences may be. Okay. Anyone got any other questions for Rishabh? And so for anyone that was on later, again, there's a link to the paper, which does warrant, I think, a thorough read through at your leisure. I'm not seeing any more questions in the chat. I don't see any hands raised. So yeah, okay. Well, in that case, thank you, Rishabh, for reprising that. That's much appreciated. And I've no doubt some people may well have some further questions once they've had a chance to sort of read through the paper thoroughly. But I think it's interesting to have actually done some of the measurement, and it will at least, I think, sort of provoke a few questions for people to investigate afterwards to try and perhaps chase down some of those performance differences. So thank you for bringing it to light. Right, and on that note, then let's move topic.
I have a question actually.
Oh, sure. Go on, no.
Yeah, sorry. So I think what would be interesting, Rishabh, would be if you consider a large multinational company with a lot of different presence points in multiple countries. I think it's interesting to consider if they can move to a DOH server. What you are basically saying is that they would obviously, their employees based in some countries would experience a degraded service should they move to DOH versus what they are using today. Is this fair as well?
So,
or is it more complicated?
So you're saying if we consider multinational companies and their employees working at those companies, they're since these MNCs have lots of points of presence around the globe, they're gonna enjoy a speed up. Am I understanding that correct?
Well, yeah, a speed up or a degradation.
Oh, if it's gonna be the same for all the employees. So I am, based on the research, I'm tending. I want to say that at the end of the day, it does come. So first thing I want to mention is that we did it in residential IPs. So my conclusions are based on what people in residential sectors were facing. So I think the question then boils down to how much the MNC in the country invested in internet infrastructure, and if that's enough to offset, let's say, the broadband speeds and the internet infrastructure that's already in that country. So because the one thing that overwhelmingly stood out was if your internet infrastructure is not great, you're not gonna you're gonna have a bad degradation. So I wouldn't say that it would be equal across all the countries, because for each country, the kind of internet that's present in the country does play a major factor into the equation. So, but if if the MNC can find some way to have equal internet across all the countries, then yes, it would be the same performance. But if they can't ensure that, I don't think that would
I don't think yes, thank you. I don't think companies can have an equal footing everywhere today already with what they have today, because they have to rely on what they are given. They cannot rebuild their own infrastructure by themselves. So it's interesting to see that it would, for some of their employees, it would degrade furthermore the experience. Okay, thank you very much. Very interesting.
Thank you. And that was a sort of closing comment on that. I see Alice has posted a comment in the chat, which is DNS over UDP performance is often or is likely impacted by cheap CPE that runs a very crude DNS proxy forwarding request to the ISP servers, often not caching. So potentially, to perhaps sort of rephrase that, the DNS over UDP certainly is potentially not optimized.
Right.
To the same extent, so that may well also impact on performance in at least some markets.
Okay.
Anyway, okay. Well, thank you for that interesting study. So thank you, Rishabh. I hope people found that useful. Right, let's then just move on to a couple of other topics. So I will reshare my screen. So I mentioned earlier, I think there's been some interesting developments over the last few weeks, which you would have seen in my sort of weekly news headlines email, but I just sort of called out 4 of those just to highlight. In the order that I put them in the email. So firstly, Android 13 apparently now does have native support for Doe, which was a little delayed, was originally expected earlier this year. So Tiramisu now has Doe support. And you can see a link to more details on that on the slide, which I'll share after the call. More interestingly, maybe after the discussion that we had at IETF 113 all those weeks ago, sort of 3-4 weeks ago now, in Vienna, about some of the challenges posed to end users by encrypted client hello. I was very pleased to see an announcement from Google, which Kenji posted to the Eddie mailing list the week after IETF 113, that at least for now, Google's rethought how to implement support for ECH within the Chrome browser. The sort of first link in this bullet point takes you to sort of Kenji's announcement, in case you haven't seen it, but at least for now, they are looking at options to switch off ECH support within Chrome, potentially in the corporate environment. So more details on that link. Importantly, though, if that's something that you believe is sort of useful, or you have other views on the approach being taken, or perhaps think there may be a better way of doing it, now's the right time to feed that back to Google. So they've asked for input on this issue. So please make sure that you take the opportunity to provide that input. And as I say, more details in the announcement from Kenji. And then 2 other things. One I wanted to highlight was more evidence of malware using Doe, in this case, the Denonia malware, I think running on AWS. It's a Go-based crypto miner, which is using Doe to make itself harder to find. It's not the first example, but it's one that came up in the last week or so. And then finally, and perhaps most immediately interesting, Rode Schwartz, who've sort of been on our weekly call recently, have just announced support for a new sort of DPI engine, specifically tasked with identifying encrypted traffic. They've launched a new product through one of their companies. And it claims to work on a very wide range of protocols. If from memory, I think the press release suggests up to about 1,000, but it specifically names TLS 1.3, ESNI, ECH, DOT, and DOE, amongst, I think, a plethora of other types of encrypted traffic that the DPI engine is able to identify. So I thought that was worth flagging to this group as likely to be of interest. The link to the article included again on the slide. And then finally, from me, before we move on to any other business, in terms of future call topics, next week is a public holiday in the UK and at least a number of other European countries. So I wasn't planning to have any speakers on the call, but happily open up the call just for a general chat if there's interest in doing that. So indicate in the chat if that will be useful. And then going forward on the 9th of May, Paul Grubbs from the University of Michigan is going to join us to talk about encryption and policy enforcing zero-knowledge middle boxes, which is hard to say, but Paul can expand on that. He'll be reprising a talk he gave at a recent conference, which was recommended to me. I'm planning on the 16th to sort of schedule our sort of much trailed sort of general discussion on shared learnings from deployment of support for encrypted DNS resolvers. So a number of people have indicated they'd be interested in being part of a panel discussion on that. If you'd like to join them, please contact me directly, and we'll have maybe a handful of people who've got some sort of hands-on experience of deployment over the last couple of years or so, just to share their respective learnings and just have a general conversation. Later in the month, on the 23rd, Mallory Nodal from CDT will join us with a more policy rather than technical focused discussion around legal challenges from around the world on encryption, which we'll talk through. And then in terms of future topics, which I haven't yet got a date for, I will reschedule Andrei Meshkov to talk about some of his shared learnings, share some of his learnings from deploying his DOQ resolver. I've already reached out to Rode Schwartz to talk about their DPI engine on the assumption that will be of general interest, and also the authors of a paper on a survey on DNS encryption and malware to also get on the call. So we'll start to pin down dates for those as we get probably through June. So that should take us a good way through the first half of the year. So those are topics that are planned. As always, if anyone's got any other topics you think would be useful to cover, then please just drop me a line or raise it on the call now, that'll be fine. But with that in mind, I thought we'd move on to any other business. So I'll stop sharing and see. But if anyone's got any comments on any of that, or indeed if there's anything else that you picked up on over the last few weeks that you think it would be useful to highlight. So as before, either put comments in the chat or use the Zoom tool to raise your virtual hand and see what you think. So anything from anyone that you want to raise this week? Not seeing any hands raised at the moment. just give it a minute or two.
Andrew, Arnaud speaking.
Sure, far away, Arnaud.
Yeah, so very quick. I'm continuing to discuss with structured workshops with my customers, top 100 customers in Fortune 500 in the international area, about the ECH situation. And yeah, I have a lot of customers who are really shell-shocked to discover what's going on. And the community that is building up starts to really ask a lot of questions about why on earth we are in this situation. So I'm trying to structure some kind of answer. I don't know yet what I'm going to do, but I'm continuing getting quite some interesting feedback. And it's not like light discussions in the corner of a lunch, right? It's proper 2 hours workshops with slides with their teams, and this is reaching now a couple of head of networks at group level. So it's really shocking to be told by some parties that enterprise customers are not doing proxy. I mean, this is just like a joke. But anyway, I will continue to do that, and we try to regroup in the synthesis what I'm discovering. Over.
Okay, thanks, Arnaud. That's helpful. Maybe that's a topic we'll revisit over the next few weeks. Then, perhaps as you consolidate some of that that feedback, that could be quite useful to come back to and discuss. Anything else on people's minds? Anything else anyone wants to raise this week? Not seeing anything in the chat at the moment. I can't see any raised hands. Just one question I'll just throw out as I can see John on the call. Is there any further update on the Quad 9 court case in Germany, or is that just still going through the legal system?
Yeah, no updates, but I suspect there'll be something in here in the next 30 days or less.
Good, I think.
Good, bad, hard to say. Yeah, at least it's moving forward.
Yeah, true enough. Okay, good. Okay, well, in that case, let's draw a line there. So thanks, everyone, for your time. Particularly, thank you, Rishabh, for coming on the call and sharing your sort of the results of your testing. That was most helpful. And as I said earlier, I'm sure that will lead to a few people sort of going back through the paper and reading it in more detail. So it certainly raises a number of interesting issues. So with that in mind, thanks everyone. Have a great week. And as I said, it's a sort of public holiday in parts of Europe next Monday, but I will open up the call for a more sort of just general conversation if anyone's around wants to have a chat. So maybe speak to them if not, certainly Monday week. So have a great week and speak to you soon. Thanks all.
Thanks, Andrew.
Andrew.
Thank you. Bye.